All right, let's dive right in. Welcome back to another High Yield Explainer. Today, we're delivering a highly targeted executive briefing. We're going to decode Kubernetes operations and the Certified Kubernetes Administrator, or CKA certification. Whether you're a tech leader overseeing infrastructure or an engineer looking to validate your skills, this briefing is custom built to maximize your time. We're giving you the absolute core of what you need to know.
Hello, everyone. Welcome to this channel. Listen, we know your time is incredibly valuable, so we're taking a strict bottom line upfront approach today. We're cutting through all the noise to deliver straight facts. So grab your coffee, lock in, and let's get started. Just a quick look at our agenda for today. We'll start with the Kubernetes landscape, move right into demystifying cluster architecture, cover storage and installation strategies, discuss mastering the CKA exam, and then we'll wrap the whole thing up with rapid cluster troubleshooting.
Okay, Section 1, the Kubernetes landscape.
Now, you might find this interesting, but the Linux Foundation's CKA exam actually has no formal prerequisites to register, none at all. But in practice, well, skipping the basics is exactly why so many people fail on their first attempt. For sure, you absolutely must have foundational skills in Linux administration, things like managing systemd services and networking. And alongside that, you need a solid grip on YAML and JSON configuration, simply because that's the primary syntax for defining your Kubernetes manifests. Without those basics under your belt, managing containerized applications at scale becomes a massive uphill battle. Moving right along to Section 2, demystifying cluster architecture. So think of a Kubernetes cluster kind of like a corporate hierarchy. It really helps to visualize it this way. The control plane, which you see on the left, is your C-suite. It's making all the global administrative decisions and managing the cluster's overall state. Meanwhile, on the right, the worker nodes are your frontline employees. They aren't making strategic decisions, they literally just execute the actual workloads, your application containers, and make sure they stay up and running. Now, zooming in on that C-suite, we have the API server. You can think of this as the primary communication hub. It essentially acts as a hyper-efficient executive assistant for the entire cluster. Every single REST request, whether it's coming from an external client or an internal component, routes straight through this API server. It's the ultimate gatekeeper. And the best part, it never takes a day off. Rounding out the control plane team, we have etcd. This is a highly available key value store, and it acts as the infallible corporate record keeper. It holds the absolute truth of the cluster state. Then, over on the front line, on the worker nodes, you've got the kubelet. The kubelet is basically your frontline manager. It takes orders from the API server and makes absolutely sure the necessary containers are actively running and healthy in their pods. All right, Section 3, storage and installation strategies. When it comes to actually installing this stuff, you generally have two primary paths. On one side, there's Kind, which stands for Kubernetes in Docker. It's incredibly fast, it's lightweight, and it's absolutely perfect for local development or just learning the ropes. But for real enterprise operations, you need kubeadm. kubeadm bootstraps a true production-grade cluster. It handles high availability setups with multiple control planes sitting behind a load balancer, and it manages all those incredibly complex security certificates you need for scaling up. Now, let's talk about storage because that's another major operational hurdle. Static provisioning relies on manual administrative setup. That means your storage admin literally has to physically pre-create persistent volumes or PVs for developers to use. Dynamic provisioning, on the other hand, is where real enterprise scale happens. It uses a really clever feature called a storage class to automatically provision storage on the fly, the exact moment an application requests it. Game changer, right? But whether it's dynamic or static, the developer's workflow is exactly the same. They create a persistent volume claim, or a PVC. As long as the requested capacity, the access modes, and that storage class match up, Kubernetes just seamlessly binds that PVC to the actual physical storage of the PV. It acts as this magical abstraction layer, completely hiding all that messy underlying infrastructure from the application developer. Let's pivot slightly to Section 4, mastering the CKA exam. Now, what's really interesting about this next section is visualized right here. This is the official exam weightage. Take a look at that slice for troubleshooting. It makes up a massive 30% of the exam. If you combine that with cluster architecture and installation at 25%, you're looking at over half of your final score right there. From an executive training standpoint, this is absolutely crucial. It clearly dictates exactly where your teams need to focus their time to actually see a solid return on their training investment. So how do you tackle this? Well, the source material breaks the prep down into a 6-part study plan: fundamentals, workloads, storage, networking, architecture, and troubleshooting. But honestly, the bigger takeaway is how the author heavily emphasizes leveraging James Clear's Atomic Habits framework. See, the CKA is a 100% performance-based, hands-on exam. There are no multiple choice questions here. Consistent daily operational practice in a live terminal is literally the only way to pass. Last-minute cramming, it simply will not work. Furthermore, you have to remember this exam is a brutal, strict 2-hour trial with 15 to 20 practical tasks. So time management is everything. There are 3 non-negotiables if you want to survive. 1, you must master imperative kubectl commands to generate resources instantly, rather than writing YAML out by hand. 2, you need to leverage the pre-configured k-alias for kubectl to save keystrokes. And 3, you absolutely must know your Vi editor shortcut so you can save and exit rapidly. Pure efficiency is how you win this thing.
Okay, moving to our final segment, Section 5, Rapid Cluster Troubleshooting.
When containers inevitably fail, and trust me, they will, you need a rapid step-by-step checklist. You should always start with kubectl get pods, and then use kubectl describe pod to view the event history. If you see an image pull error, look for a typo in the image name or maybe a missing credential. If you hit a crash loop backoff, which is where the pod just keeps continuously restarting, use kubectl logs to hunt for application errors, missing dependencies, or resource constraints. It's really just a systematic process of elimination. At the infrastructural level, safe node maintenance requires a lot of precision. Before you patch a server, your team has to use kubectl cordon to mark it as unschedulable. Then they use kubectl drain to gracefully evict and move all those running workloads over to other healthy nodes. Oh, and for security and governance, we rely on admission controllers, like webhooks. Think of them as strict checkpoints that either validate or mutate API requests before the cluster ever even executes them. But here is the million-dollar question. What happens if the API server itself goes down? If your C-suite is suddenly offline, your standard commands are just going to throw connection refused errors at you. You need an ultimate fallback protocol. Your engineers actually have to SSH directly into the master nodes, bypass kubectl entirely, and use a tool called Crictl to interface directly with the container runtime. From there, they can debug the API server and etcd logs to figure out exactly why the control plane crashed in the first place.
And that brings us to our final thought for today's explainer. Kubernetes offers unbelievable power, but it demands really rigorous operational discipline. So ask yourself, is your enterprise cluster truly self-healing? And maybe more importantly, if the C-suite goes down, is your team actually equipped to prove it and fix it under immense pressure? Think about that as you evaluate your own organization's readiness. Thank you so much for joining us, and we'll see you next time.